So, sequences and series. Now, actually, these two questions they are sequence, not series. I'll still treat the question on series if time permits me. So, what differentiates a sequence from a series is if we are adding the summation of a sequence gives a series. Assuming here I'm putting plus, 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 then that's a series. But for now, it's a sequence. Now, this is we don't know whether it's an AP. In fact, it's not an AP originally because there is no common difference. The difference between here is 3, why this is 4, this is 5. They are not the same. Same thing with this. So AP follows a pattern that has no common difference between each term. So how are we going to do it now? Solution. Question 1. Now, what's our A1? Our first term equals to 2, right? Our second term equals to 5, which you can write as 2 plus 3. You have to break it down by writing the initial one first. Our A3 is 9. First write this 2. 2 plus 3. What do you have left to make it 9? 4. Our A4 equals to 14, which is 2 plus 3 plus 4 plus 5. Our A5 equals to 20. That's 2 plus 3 plus 4 plus 5 plus 6, right? So our AN, we can now create a series now that follows the AP pattern. 2 plus 3. If A5 is the, then N is a number that we assume, probably the 10th term or 100th term, plus 4 plus 5 plus 6 plus 6 plus dot 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 plus x. Let's say the last term there is x. Now, because we break this down, this is 2, the next one is 5, this is 5, 9, 14, 20. Now, because of the breakdown, we are able to create, a series, right? An AP series to be precise. So we can use this one to generate. The question is, find the nth term. We want to look for the nth term. Find the nth term. The nth term of the sequence. So now we can now use this pattern because it follows the AP series to find our nth term. Now we can now say that our first term here, our A equals to 2. What's our common difference? We can use this. Our common difference is what? 1. Why our n equals to what? Unknown. So now, if we want to find our nth term, we are not going to use Tn. We are going to use Sn, sum of AP. Why are we using Sn, sum of AP, instead of Tn? Why? Because this is summation, this is series. No, this plus this is summation, so we are using sum of AP. So Sn equals to n over 2 into what? 2a plus what? N minus 1 into what? Into d. So Sn equals to n over 2 into 2a. What's our a? 2. 2 times 2, 4. Plus what? N minus 1 into what? Into d. Our d is 1. So this gives us n over 2 into what? 4. N times 1 plus n minus 1 times 1 minus 1. So this gives us what? N over 2. 4 minus 1, 3, right? So here we have n plus 3. N over 2 into n plus 3. So using this and sum of AP. Now this is our nth term now. You can decide to open the bracket. If you open the bracket, n times n, you have n square. N times 3, we have 3n, then over 2. Now let's check if the answer is correct. Let's put n equals to 1. If our n equals to 1, are we going to get 2? 1 plus 3, 4 over 2, that's 2. If n is 2, are we going to get 5? 2 square, 4. 3 times 2, 6 plus 4, 10 over 2, 5. If n is 3, are we going to get 9? Yes. Let's use this one too. If n is 1, are we going to get 2? Yes. If n is 2, 2 square plus 6, that's 10 over 2. Are we going to get 2 plus 3? 5. No, you break this down. So if n is 3, using this, you have to get 2 plus 3 plus 4. But if you want to use this, if n is 3, you have to get 9. So the equation is valid. This is our nth term. Like, the formula is valid for any nth term you want to find. So that's that for that. Now, the second question, we have our A1 equals to what? 3. Our A2 equals to 6, which can be written as 3 plus 3. Our A3 equals to 10, which can be written as 3 plus 3 plus 4. Our A4 equals to 15, which can be written as 3 plus 3 plus 4 plus 5. Our A5, which is 21, which can be written as A5 equals to 3 plus 3 plus 4 plus 5 plus 6. Now these are A5. Now we can now generate for AN. Are we together? So our AN can be written as 3 plus 3 plus 4 plus 5 plus 6 plus 6. Then we have what? Plus dot 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 plus what? You can say plus y or plus x. Just fit the last term. Now we are able to generate a series by breaking down this sequence. Now, see now. The com actually the we cannot just use formula for AP here. Why? Because there must be a common difference. But this one disobeys. The common difference between 3 and 3 is 0. Why? From year to year, the common difference begin to be tally. 4 minus 3, 1. 5 minus 4, 1. 6 minus 5, 1. So the common difference begins to tally. Now, if we want to find our end term using summation of AP, it's going to give us. Now, we are going to exclude this. For the formula of AP to be applicable, this must not be there because the formula contains D, which is known as common difference. But this one doesn't fit into the common difference pattern. So this must not be there. So we are starting from here. The common difference between here now is 1. So which means our SN will give us 3. That one that will remove plus the summation of all these then will give us that first one plus the summation of all this one. The summation of everything will give us this plus the summation of this. Now, if we want to find the summation of this, no, the whole series is no longer complete again. Why? Because we've removed 1 from it. This one is no longer part. So our assuming the number in the series before is 10, since this one is no longer there, the number will remain 1. Will remain 9 rather. We've removed this. One of those terms is no longer there. So instead of n now to be 10, n will be 9. So instead of n, we now have n minus 1. So this one will give us Sn minus 1. Assuming we are removing the first two terms, it will be Sn minus 2. But we are not removing it here. We are only removing the first one because it's the first one that doesn't tally. So to find our Sn now, is 3 plus Sn minus 1. So wherever you see n, you are going to put n minus 1. So our Sn now is equal to 3 plus, the formula normally is Sn equals to n over 2 into what? 2a plus what? N minus 1 into what? Into d. So here now, we are going to use n minus 1 over 2. That's for Sn minus 1 into what? 2a plus what? 2a plus n minus 1 minus 1. Normally, it's n minus 1, but since n is n minus 1 into d. What's our d? Our d is 1. Common difference. If we check the common difference is 1. So this gives us what? 3 plus n minus 1 over 2 into what? What's our a? Our a is 3. This is where the AP starts. Even though they are the same 3, this is not our a, this is our a, because this is where the formula becomes applicable. 2 times 3 is 6 plus n minus 1 minus 1, n minus 2 into d 1. So here we have 3 plus what? N minus 1 over 2 into 6. N times 1, n minus 2 times 1, minus 2. Minus 2 plus 6, 4. So here we have n plus 4. Because n times 1 is n. So we have n plus 4. So this gives us 3 plus n minus 1 times n. Is going to give, you can open the brackets. N times n square. N times minus 4 minus 4n. Minus 1 times n minus n. Minus n minus 4n minus 5n. Minus 1 times 4 minus 4. Divided by what? Divided by 2. Don't forget, this 2 is not part of this. Now, you can now find the LCM. The LCM is what? The LCM is 2, right? So, the LCM is 2. This over 1. 1 into 2, 2 times 3. 6 plus n square minus 5n minus 4. So, what? 6 minus 4? That's 2. So, here you have what? N square minus 5n plus 2 divided by 2. That's our n term. Now let's check. If n equals to 1, are we going to get 3? Now let's check if that is valid. 1 minus 5. Coming, I'm trying to check. If n is 1, 1 minus 5, that's minus 4. We are not going to get 3. I think there's a mix up somewhere. Let's check very well. Oh, sorry. N times n, n square. N times 4, 4n. Minus 1 times n minus n. 4n minus n. Minus, this should be plus 3n. Plus 3n. Then minus 4. See, n times n, n square. N times 4, 4n. Minus 1 times n, minus n. Minus n plus 4n plus 3n. So that 5 it becomes, that's plus 3n. Plus 3. So now let's check if it's valid. If our n is 1, 1 plus 3, 4 plus 2, 6, 6 over 2, 3. If n is 2, 4 plus 6, since n is 2, 10. 10 plus 2, 12, 12 over 2, 6. If n is 3, you get 10. So you see that you get 3, 3 plus 3, 3 plus 3 plus 4, make it 3 for this one. 3 plus 3, 6. 3 plus 3 plus 4, 10. So if your n is 3, see that you get 3 plus 3 plus 4, or you get 10 alone here. So that's that for that. So this our nth term. Like an nth term means a particular general formula that you can put n that and will produce each term or summation of any first n terms. So probably this will be the last question that this. Now this is another question. 7 plus 7, this now is a series because there's addition. Now let's generate our A1 is what? 7. Our A2 equals to what? 7 plus 70. You can write your 70 as what? 7 times 10. If you like, there's no problem. Our A3 equals to what? 7 plus 70 plus 700. 7 plus 70, 77 plus 700, 777. So our A4 equals to 7 plus 70 plus 700 plus 700 plus 7,000. So our AN now will give us what? 7 plus 70 plus 700 plus 7,000 plus dot plus 7. You can decide to write x there. You can decide to write x, and you can decide to write, assuming I'm using times 10 times 10, 7 times 10, this one will give me 7 times 10 square, 7 times 10 square, 7 times 10 cube. I will have 7 times 10 cube here. So this one will give me 7 times 10, 7 times 10 raised to power n minus 1. Or you can decide to just put a single term here as x. Why n minus 1 and not n? Now listen, when you are at 8a2, when you are 8a1, if you want to multiply this by 10, it will carry a power of 0. When you are 8.2, this will be 7 times 10 raised power 1 that will last. 8.3, 7 times 10 raised power 1 is 17. 7 times 10 raised power 2 will be 700. So the power of 10 will be 2 here for 8.3. A4 stop at 7 times 10 raised power 3. A4. So the last power is 1 less than the term here, fourth term. Then the power of 10 here, 7 times 10 raised power 3 is 3. So for nth term, the last power will be 1 less than n. Since the fourth term, the last power here, I can change 700 to 7 times 10 raised power 3. The power there is 3 for fourth term. For third term, the last power is square. For second term, the last power is 1. So for n term, the last power will be n minus 1. So that's one of the things. If I want to be changing it that way. So now, you can see now that what's our A here? So here now, what's our A? A equals to 7. R equals to 10. This is a GP now. 70 divided by 7, 10. 700 divided by 70, 10. This over this, 10. And n equals to unknown. So here, instead of AP, we are using formula for GP. Sum of GP to be precise. So sum of GP, UN, equals to A into R raised power n minus 1 over what? R minus 1. That is when R is greater than 1. If R is less than 1, we have 1 minus this, 1 minus this. But if R is greater, we have R first. So now our A is 7. So this one becomes 7 into 10 raised power n minus 1 over what? 10 minus 1, that's 9. So that's our expression. Or you can write it as 7 over 9 into what? 10 raised power n minus 1. Now, if your n is 1, are we going to get 7? Let's check. If your n is 1, 10 raised power 1, 10 minus 1, 9. 9 cancel now, you get 7. If your n is 2, are we going to get 77? Or are we going to get 70? 7 plus 70, which is also 77. 10 square, 100 minus 1, 99. 99 divided by 9, 11. 7 times 11, 77. So this formula fits into, so this is our end stem. That's that for that. Thanks for watching. Don't forget to like and subscribe. And see you in the next sequence and series video. There's going to be another video that will be released on sequence and series. Thanks.